molecules are similar to long, drawn-out rods. As with crystalline structures, these molecules exhibit a strictly ordered crystal structure. The ordering of the molecules creates a directional orientation. In most LCD displays, the liquid crystals are embedded between two glass plates rotated by 90 degrees. This formation produces what is known as a twisted nematic LCD. A polarization filter is fitted onto each of the outer glass plates. These polarization filters mean that only one dispersion direction of multiple light waves emanating from a light source is allowed to pass through. The light follows the rotation of the molecules and, twisted by 90 degrees, hits the outer polarization filter. As the rotation means that the direction of the light matches that of the polarization filter, the light can also pass through this filter and brightens the outer glass plate at that point. If an electrical field is then generated between the glass plates, the special property of the liquid crystal molecule becomes fully apparent. As the molecules are dipolar, they react to the electrical field and are repelled. The rotated molecule structure is interrupted. When light then passes through the first polarization filter and follows the direction of the molecules, this hits the outer polarization filter and cannot pass through it. This means that the outer glass plate remains dark. As with a light switch, switching an energy field on or off can be used to determine whether or not the LCD display allows light to pass through it. When a matrix is created from a number of these individual cells, it becomes possible to display graphics and images. To generate more colors, each pixel is divided into 3 subpixels. Color filters are placed over these subpixels in the colors of red, green, and blue. By triggering the subpixels differently, additive color mixing can be used to generate each color required.
Then all the light will be let through, as they're both, well then it'll look like all the light's been let through. And you can rotate them to give varying degrees of light letting through. In Twisted Nematic, the polarizing filters are put 90 degrees to one another. This is a diagram of a subpixel, which is what the LCD is made of. First up, we have a backlight which provides light to illuminate the screen. Next we have the polarizing filter going horizontally. And then we have a sheet of glass which separates the filters from the liquid crystals. And we have a thin film transistor next, which provides electric current to change the direction of the crystals, followed by a polyimide. These control the direction that liquid crystals face when they are all in the cell, so they control the starting direction. Then we have the mixture of liquid crystals to polarize the light. This layer is around 5 to 10 micrometers thick normally. It can vary. The liquid crystals have to be attached to the back of the panel for this technique, which is why the polyimide is there. Then there's another polyimide layer, after which is an electrode which finishes off the circuit, so the electricity flows from here through to there. Then another sheet of glass to separate the filter. Finally, another polarizing filter, which is 90 degrees to the other one, so if the liquid crystals don't polarize at all, then no light gets let through, and if they polarize completely, then all of the light gets let through. And finally, there's a color filter, which is one